So this story about data alignment specifically relates to using time series data for predictive forecasting models. And this challenge came up when I was working with a client who's a global geodata provider. They have offshore assets all around the world, and they tasked us at Casne to develop a global data platform. So we need to get data from all those assets, get into the cloud, and make it available for their army of analysts and data scientists. And this issue of alignment came up on one of the first use cases that we took on, and that was creating local weather forecasts off of offshore helicopter pads. Now, the weather in the ocean can be way different than the weather on shore, and you can't use those onshore data sensors and weather sensors to try to predict what's happening offshore. You've got to use your own sensors. We're going to use that data and those forecasts to then determine, would it be safe to send a helicopter out to the site? So this was a safety critical use case, so we needed to have the best possible predictions possible, otherwise we could be putting somebody's life at risk. So I mentioned, we have to use our own weather sensors out there, and weather sensors produce highly homogeneous data. And when I say homogeneous, I mean the data is delivered from the sensors as a single package, and all of the data in that package is mathematically related to each other at an instantaneous point in time. And the problem that I'll go into is that typically when you use a traditional historian, you need to silo that data into tags. And the disclaimer is this was before Casne had found about TDengine. So this wasn't a TDengine project. The historian that we were working with, we needed to break that data apart. And when you silo that data into tags, you can lose the alignment of data, which can cause issues when you then go back to perform analysis on it. So what happened exactly is we took data from those weather sensors, and these sensors, there was no out-of-the-box driver to get that data into our historian. We needed to create our own custom driver. And so what we did was we took the message and we had to figure out how are we going to get it into tags. So we break it apart and we write code that basically takes that data. And one thing that's important here is this sensor was not providing its own timestamps. So we need to figure out how are we going to get a timestamp associated with the data. So we go through that message, we break it into a big loop, we take the first value, we find a timestamp, we smash them together, send it to the historian, wait for a success reply. Then we move on to the next one. We do the same exact thing. We take the value timestamp, smash them together, put it in, wait for success until we finish the list. Well, what was happening was because there was that wait for the reply from our historian's API, now that we've been successful, we started to accumulate an offset between the data and the message. So, it's really tiny. I mean, this is like code processing speeds and a little bit of networking delay, very tiny offsets. And if you were just monitoring or stuff like that, it wouldn't have even been an issue. But we handed this data set and the historian off to the data analysts. And most of the time what your analysts have to do is undo all the work that you just did to get your data into the historian, and they go to realign the data. And they started using it for predictions, and they found all of a sudden that their models were diverging. These models were super, super sensitive, and when they went and reinterpolated the data, get it all back on the same timestamps, all of those little errors added up over thousands and thousands of data points, and we no longer had a good prediction. So in this case, we got really lucky, right? We were still in the design phase, and we were working directly with our users. So we had an easy fix. Let's just take a timestamp before we break apart the message, make sure we always have the same time applied to everything that was in there. Just get rid of the problem at the core. But we were also lucky, since we were so close to the users, that they could tell us the needs of their use case in basically real time. We could go make that change. So not everybody is going to be that lucky, and I've seen tons of historians that have decades of data in them that's just not suitable for prediction. And it's because whenever those things were implemented, either the technology they were using or the design didn't account for the future that we're living in today. And this is a future where predictions are starting to become essential for operations. Right? That was the whole point of this use case, was predictions. So something that we have to look forward to and look out for moving forward is that when we design these systems, we need to make sure that the active historizing itself does not break apart and disrupt the alignment of the data, because that alignment is now more important than